Okay, so here we are going to practice the laws of properties of logarithms. Here's Dave number 2. So I do number 1. The expression log radical xy is equivalent to, well, there's 2 changes here. First of all, I'm not telling you whether we are condensing or expanding. You need to figure that out. Since there's only a single logarithm here, we know that we need to expand to multiple logarithms. The second thing is that we have radicals, so we need to handle that a little differently. First thing we need to do is we need to rewrite the radical as a fractional exponent. So we recall that square root is really to the 1/2 power. Another thing that's very important is that you keep xy inside the parentheses because 1/2 power pertains to both x and y. Then we can apply the power rule. So we bring our exponent down to the coefficient. And finally, we can apply the product rule using parentheses. Here's one that's similar to the previous one, except it's in a fraction. So again, we are expanding this, and we have log radical xy over z. First thing is to rewrite the radical as a fractional exponent. And then we can apply the quotient property, log of xy to the 1/2 minus log of z. And then what we can do is we can handle the power here, 1/2 power, bring it down as the coefficient. That's the power property. And finally, we can handle what's inside the parentheses here, which is log of xy, which is the product property. So log of x times y is really log of x plus log of y. And the 1/2 remains in the front, multiplying both of these. You could also distribute this, which would be an equivalent expression. So you can describe number 2. So this one, we are also expanding. So first thing we do is we rewrite the b as a radical, as a fractional exponent. So we have log of a times b to the 1/2 all over c. Then we can apply the quotient property. Then we can apply the product property, log of a plus log of b to the 1/2 minus log c. And then finally, the power property, the 1/2 comes down in front like this. This is the coefficient. Okay, are we expanding or condensing? Well, if you said we are condensing, you are correct, because we start off with multiple logarithms, and we want to condense this down to 1. We want to unsplit this. First thing we're going to do is we're going to apply the power property. We're going to take the coefficients and move them up to the power, to the exponent. So that's the power property. And then I'm going to rewrite this fractional exponent as a cube root. And then I can apply the quotient rule, or the quotient property. And now we can see we have condensed this expression down to this expression. All right, same thing, and we're going to condense. Let's take the coefficients, write them as powers. That's the power property. Rewrite the fractional exponent as a cube root, and then apply the quotient rule, and this is our final condensed expression. The speed of sound, v, at temperature T in degrees Kelvin, is represented by the equation v equals 1087 times radical T over 273, which expression is equivalent to log v. Well, the first thing we're going to do is rewrite this radical as a fractional exponent. Now notice the use of the parentheses around the entire expression T over 273 because it originally was under the radical. And now that we have this, I'm going to recognize that there's an invisible multiplication sign right there, and we're going to apply the product property. Next thing we're going to do is apply the power property. 1/2 goes in the front. And now we can apply the quotient property. And notice that the 1/2 is left in the front of these parentheses. We could distribute it, and this would be the distributed form of the answer, which you should be able to recognize if this were in a multiple choice option on the test. And finally, here is the last one of the day. It's another, based on the laws of logarithms, log r can be represented by what? So this right here, a black hole is the region in space where objects seem to disappear. A formula used in the study of black holes is the Schwarzschild formula. R equals 2gm all over c squared. So we're going to take the logarithm of this. We're going to apply the quotient property first, then the product property. I kind of did all of these 2gm all in one step, so it's log 2 plus log g plus log m minus log c squared, and then finally the power property like this. This is our final answer, and there's the lesson. Best of luck to you with properties of logarithms.